The third example here, we're going to be using the English system. This is what we use here in the United States. This one says a vertical right circular cylindrical tank measures 30 feet high and 20 feet in diameter. It is full of kerosene weighing 51.2 pounds per cubic feet. How much work does it take to pump the kerosene to the level of the top of the tank? So let me start by drawing a picture of this tank. So it is a vertical right circular cylindrical tank. So it's going to look something like this, though pardon my drawing skills. Says it's 30 feet high, and it has a diameter of 20 feet. That means it's got a radius of 10 feet. So to find how much work it's going to take to pump this kerosene to the top of the tank, we're actually going to be looking at how much weight of kerosene we have at any given time, or at any given height, technically. So what we're going to do here is we're going to find the volume, and then we'll be multiplying that volume by that 51.2 pounds per cubic feet. So what I'm going to do is I'm going to let X equal the height of the kerosene. So we're going to be pumping kerosene into this tank. So the X value will start at 0 and it's going to go all the way up to 30. So that's our lower and upper bounds when we're going to integrate there. So if X is the height of the kerosene, the volume of kerosene sorry if you're picking that up, it's storming here while I'm recording. The volume of kerosene is pi times the radius squared times the height. So pi times the radius, which is 10 squared, times the height, which is x. So the volume of kerosene is 100 pi x, and it would be cubic feet in this case. So that's the volume. Now, force, in this case, it's force due to gravity, so it's going to be the weight of the kerosene. To find force, you're going to take this 51.2 pounds per cubic feet for that kerosene. And you're going to multiply it by the volume of kerosene. So we're going to take that times the 100 pi x. And I don't have the units written in here, but it's pounds over cubic feet times cubic feet. So it's going to leave us just with pounds. Okay, so again, it's force due to gravity. So this is what we're going to end up integrating. If you want to, you can take 51.2 times 100. So we'll have 5,120 pi times x. So to find the work, we're going to integrate this from x is 0 up to 30 feet. And we have 5,120 pi x dx. The 5,120 pi is just a constant, so we're really just integrating that x, which will be x squared over 2. So you have 5,120 pi times x squared over 2. And we're going to look at that from x is 0 to 30. When x is 30, 30 squared is 900. So we have 900 over 2. And then when x is 0, it's just going to be 0 over 2. So we're taking our 5,120 pi times 450, 900 divided by 2. And when you multiply, keeping it in terms of pi just for right now, you're going to get 2,304,000 pi. And this is going to be the foot-pound. Now I just kept the pi in up to this point because it's a lot easier to write that than to write decimals and keep track of those. But if you want to get an answer without that pi, you can multiply it out. Now the answer I'm going to give you here is not using just 3.14 for pi. This is using the pi button on my TI-84. So if you were to take 2,304,000 and multiply it by 3.14, you're going to get a slightly different answer than what I'm going to give you here. But again, this is using the pi button on my calculator, and it just goes out to more decimal places. So you end up with 7,238,229.47. And again, it's the foot-pounds.